This seems familiar. Or at least this part, doesn't it? Look, it's the expanding brackets, our old friend. If you haven't seen how to expand brackets, then please learn how to expand this thing, for example, to get 5x plus 30. Then please check that out first so that you feel comfortable expanding brackets like that and like this one, because that skill will come handy to solve these equations that are getting more complicated. So, what we're going to do to solve equations like this, where there are brackets or where the variable is on both sides, is we'll follow this three-step plan. Step number one, we're going to expand any brackets and collect like terms. So the expanding brackets looks like this. X plus 6 has been multiplied by 5. The whole thing is multiplied by 5. So it's the same as saying, well, the x has been multiplied by 5 to get 5x, and the 6 has been multiplied by 5 to get 30. You can put this line in here to help you. You don't have to. 5 times x is here. 5 times 6 is here, equals 15. If you prefer, you can jump straight to this next line, which is, 5 times x is 5x. 5 times 6 is 30. And then I just copy down the equals, copy down the 15. What I've done, in effect, is I've replaced this expression here with something that is exactly the same. That expression. These two expressions are exactly the same. So I can replace one for the other. The reason I'm doing that is a reason that mathematicians use all the time, this strategy. They convert a problem that is hard, that they haven't seen before. They use a trick that they've seen before, like expanding brackets, and now we've converted it into one of these. We've converted it into a problem that we've solved before. We can solve these kinds of questions. 5x plus 30 equals 15. Well, x has been multiplied by 5, and then we've added 30. So the last thing we did was add 30. What's the opposite of adding 30? Subtracting 30. So that plus 30 on this side will turn into minus 30 on the other side. Sweet. Okay. Another way to think of it is I've got a term there, get rid of this term, move it to the other side, positive 30 into negative 30. In either case, everything else gets copied down. The 5x, the equals, the 15, it's just that the plus 30 has moved. Okay. Is there anything I can do with this line now to make it simpler? Ooh, I can see something. 15 take 30. We can simplify that. 15 take 30 is negative 15. Yes, if I have $15 on my credit card and I spend $30, then oh no, I am $15 in debt now. So I can replace this with negative 15. The therefore I copy down, the 5x I copy down, the equals I copy down, but I've just replaced that with its answer. I've finished moving terms around because I only have one term left on the left. Left on the left. I only have one term remaining on the left. So I need to somehow break this up and get the x by itself. X has been multiplied by 5 here, right? This is 5 times x. So what's the opposite of multiplying by 5? It is dividing by 5. So the x times by 5 here will turn into divide by 5 on the other side. So in other words, x is negative 15 over 5. You could have put the negative on the top, by the way. This is great. I have solved the equation, which is great. Excellent. But can I simplify it? This number looks very difficult to understand. It's written as a fraction. Sometimes I can simplify a fraction, sometimes I can't. Can I simplify 15 divided by 5? 15 divided by 5? I remember my times tables. 15 divided by 5 is 3. So let's replace this part here, the 15 divided by 5, with 3. Everything else I'll copy down. The equals, the x, the therefore, the x, the equals, the minus sign. But I've just replaced that there with 3. And that is why x is negative 3. Yay, done. Okay, we can check the answer, but yeah, let's check it, why not? We think x is negative 3. Well, negative 3 plus 6 is 3. 5 times that, times 3, really is 15, so it does work. Okay, this one. Ooh, there are no brackets to expand here, so step 1 looks like it's done. Move the unknown terms to the left-hand side of the equation. The unknown terms are the terms with a letter in it. So we have a few terms here. We've got this x term. We've got this positive 3 term. Do you notice that I include the sign that comes before it in the term? I've got this 2x term, and I've got this negative 1 term. Again, if there's a sign, a plus or a minus before it, then I include that in the term. So I have 4 terms here, and I think we're actually ready to play my favorite game. We want terms with a letter to be on the left, and terms with a number to be on the right. So we're going to play my favorite game called Is This Term on the Correct Side? This term here is x. Does this have a letter in it? Yes. Should it be? So it should be on the left. Is it on the left of the equal sign? Yes. So is it in the correct place? Yes, it is in the correct place. This term here is positive 3. Is this a letter term or a number term? It's a number term. So it should be on the right of the equals. Is this term on the right of the equals? No. So we'll have to move that one. That one's going to go over here. Okay. This term here is a letter term. So it should be on the left. Is it on the left of the equals? No, it's on the right of the equal sign. So this one is going to have to move to the left. When I say left and right, I mean to the left and right of the equal sign here. Okay, the last term here, is this a letter term or a number term? This term here is a number term because there is no letter in it. Number terms should be on the right. Is this term on the right of the equal sign? Yes! So it's in the correct place. We don't have to move it. Our goal is to get all of the letter terms to the left and number terms to the right. So let's do these moves now. That plus 3 will turn into minus 3. So I've got the x here, we'll copy down. The plus 3 will turn into minus 3. This 2x term here is it positive or negative? This 2x term is positive because there is no sign in front of it. So we assume that it's positive. So when I move this positive 2x, I move this positive term to the other side and it becomes negative. Positive 2x turns into negative 2x. Can you see that I've jumbled around the terms so that my letter terms are on the left and my number terms are on the right? Now I can start to simplify. I have one lot of x, take 2 lots of x. One lot of x, take 2 lots of x. 1 take 2 is negative 1. You can write that as negative 1 or just as negative x. This is because if there's no number in front of it, the number is a 1. Okay, and minus 1 take 3, I can replace that with the answer. Negative 1 take 3 is negative 4. Now, I know what negative x is. Negative x is negative 4. There is a cool trick, because remember we win if we know what x is. We don't know what x is yet. We know what negative x is. So a trick that you can do if you've got negative x is to flip the sign of both sides. This one was negative, so it will become positive. And this one was negative, so it will also become positive. So x equals 4. Technically speaking, what we actually did is multiply both sides by minus 1. Negative 1 times this is positive, positive 1 times that. And negative 1 times negative 4 is positive 4. But if it's easier for you to think about, I think about it as, well, I know what negative x is. So to get rid of the negative, I can flip the sign. This one was negative, becomes positive. This one was negative, becomes positive. So the answer is 4. We can check that. Let's check to make sure. On the left-hand side here, I've got 4 plus 3, which is 7. Maybe I'll put that up the top. This is not part of the answer, but I'm just checking to make sure that it worked. This side says 2 times x, or 2 times 4. 2 times 4 is 8. 8 take 1, is 7. So this number, x equals 4, makes these sides equal. Okay, I'll just clear up the screen a little bit. We have one last question here. This one's another one with brackets. So we first expand any brackets and collect like terms. I'm going to expand 2 times x is 2x, and 2 times 2 is 4. So that expression on the left-hand side turns into 2x plus 4. And on the right-hand side, I just copy everything down. If you're not sure about expanding brackets, please go back and have a look just at the basic expanding brackets questions so that you feel okay with them. All right, now we're ready for my favorite game, which is this term on the correct side? We have 4 terms here. Terms are separated by plus and minus signs and include the plus or the minus. This first term here, does this term have a letter in it? Yes! So should this be on the left or the right? The left! And is it on the left? Is it on the correct side? Yes, this one is on the correct side. Let's move on to contestant number 2. I have positive 4. Is this a letter term or a number term? It is a number term. So should it be on the left or the right? It should be on the right of the equal sign. So this term should be on the right of the equal sign. Is it in the correct place? No, because number terms need to go to the right. There we go. All right, what about this term? Is this a letter term? Yes. Should it be on the left or the right? Well, it should be on the left because it's a letter term. Is this term on the left of the equal sign? No, it's on the right. So that will have to go to the left of the equal sign. And very last one, our final contestant, please. Positive 2. Is this term a letter term or a number term? It is a number term. And should numbers be on the left or the right? They should be on the right. So that term, is it in the correct place? Yes, because it is on the right of the equal sign. So the only ones that I'm going to move are the x will move to the left to join its friend here, 2x. And the positive 4 will move here to join its friend. The positive 4 will turn into negative 4. And x here, this term is positive or negative? Positive will turn into negative x. So 2x stays there. The positive x term turns into negative x. Then I've got my equal sign. I've still got the plus 2 here. I'll copy that down. And the plus 4 turns into negative 4. Do you notice that I copied things down and checked that everything was accounted for? The x moved over here, the 4 moved over here, but the terms are still there. Okay, so we've done step number 2, I think. I think we still have some like terms to collect though. Let's go back and collect some like terms. Because here, I've got 2 lots of x, take 1 lot of x. If I have 2 bananas, take 1 banana, then I have 1 banana. So 2 lots of x, take 1 lot of x is 1x. I just realized I forgot a therefore. There it is. 2 lots of x, take 1 lot of x is 1x. Remember, if there's no coefficient, no number, you can just imagine that there's a 1 there. So 2 lots of x, take 1 lot of x, is 1x. The right-hand side, to show you what I did, I've got positive 2, take 4. 2, take 4 is negative 2. So that's the answer there. We're really, really close to the answer, but I only win if I have x equals something. But hang on. 1 lot of x is the same as x. So if ever you get to the point where you've got 1x, you can just write that as x. They're the same thing. I mean, you would agree, I'll scribble somewhere, you would agree that 3 and 1 times 3, I know we're going a little bit back to primary school here, but 3 and 1 times 3 are the same number, right? They're exactly the same number. So x and 1 times x are exactly the same number. X is always exactly the same thing as 1x. So when I see 1x, if you ever see 1x, you can just replace it with x. So the answer, by copying down the equals and copying down the -2 and copying down the therefore, is that x is negative 2. What a handy little trick. If you see 1x, you can replace it with x. Sometimes it's handy if you see x to think about it as 1x. Like here, I had x, so I thought, oh, that is 1 lot of x. Yes. So there are all these little tricks that can help you to simplify equations. All right, I will see you all on the flip side. Bye.